Hello everyone, my name is Prabjot and this is project final presentation and demonstration for a privacy by design COVID-19 contact tracing web application. Me and my team members will be guiding you through the key functionalities of our application, the issues we have identified, the solutions we have proposed. We'll be also talking about the system design and demonstrating how we incorporated security requirements into our application. Overall, this application is targeted towards mitigating spread by alerting the users that might have been exposed to COVID. It also aids health authorities by notifying them of the exposed users so that they can take precautionary measures. We adhere to the privacy by design standards by targeting privacy concerns of users, that is, their confidential information will not be exposed at any given time. Also, we made sure that data is accurate and complete at all time, and thus integrity is maintained. The application can be used by a wide range of users irrespective of their geographical locations and backgrounds. We also made sure that the application was secure from the bad attackers or bad users. The key functionalities of our application are that all the users must be successfully and securely able to log in and register into their accounts. And while the users can check into the locations and can see their history, while no one else can access or modify these check-ins for a particular user, venue owners and administrators can see the user histories but cannot modify them. And maps are visible to all the users so that they can see highly prone areas, and account settings can be changed by all the users in order to update their personal information. Administrators have higher privileges, so they can send the email to users who have been exposed and create new admins by using codes. And administrators can also change the status of the users who might have been in contact and can switch it on and off. And so we made sure that all these securities had the security aspect well addressed in them. As a group, we identified multiple overall 20 security requirements, but we targeted 9, primarily which involves strong encryption in the passwords and denial of service attack prevention. We also combated the cross-site scripting and SQL injection attack. We made sure that the application was free from brute force attacks for passwords. We also kept record of logging and monitoring activities in our application. We also combated the session hijacking attack, and we made sure that our application incorporated strong sign-up process and segmented user authorization. Now, these will be discussed more in depth by Soren.
Thank you, Prabjot, for your presentation and giving me the chance to carry out the next part of the presentation. Hello, this is Shoren Thor, and I'm going to discuss about the potential solution of design issues and the security requirements. Here, you can see the sequence diagrams with the solutions for the design issues. Our first one is like the denial of service. So previously, there was no prevention against this attack. Viewers and the brute force attack solution has been tackled in a combined manner. On front end limitations, we basically we have added a limitation on how many times a user can input the wrong credentials. If the users make the multiple wrong attempts, they will be locked out for a specific time. On the back end, we have implemented rate limitation of on users logging APIs. The next one is the brute force attack. So previously, as usual, there is no security measures were in places. So now the front end limits the logging attempts into the tree, logging users for a period after consecutive failures. The backend also restricts requests after a set threshold, preventing brute force attack. The next one is the cross-site scripting. So before bigger user input handling on web pages was really difficult and primitive and unformatted. Also, there was no DOM injection since input validation was put so into place. All user data has been thoroughly examined and cleaned. So it ensures all kinds of security facilities now. So the next one is the SQL injection. So in the app's previous version, no input validation measures was taken. By adding a function to escape malicious characters in user input, preventing SQL query execution. Even server-side queries are parameterized. The next one, the strong sign-up process. So we have ensured email verification to differentiate between the authentic user and the malicious attacker. Implemented strong password creation rules, like password must be at least eight characters long, a lowercase number, or a special character. Also a valid email ID, including @ and the validate all kind of input fields to expected data types. The next one is the strong encryption. So previously, the project transmitted sensitive information like passwords in plain text from the front end, posing a security risk. To enhance security, we have implemented the double encryption. So next, go to our slide. That is the session hijacking. So previously in this project, there were no security measures against the session hijacking, any kind of attacks. We introduced secure cookies by the turning on the HTTP flag to make sure that no one from the client side can alter the session cookies. Our next issue is the logging and the monitoring. So combined logging is used to find out the necessary data for future analysis and auditing, and also the monitoring robust issue detection any malicious logging items, and increasing system performance and solving future problems. The next one is the segment user authorization. This is the last one. So role-based access prevents any kind of unauthorized entry. So users are restricted user capabilities. Only admins can change the roles and the create new admins mode. So the next slide is represents the synopsis, the all kind of the technical terminologies, and that's all about the solutions for the issues. And thank you for your time. Now I'd like to ask my colleague Uma to carry out the further of this presentation. Thank you for your time. Thank you. See you.
Thank you, Surin. My name is Uma, and this is my system design. The first one is the class diagram. This class diagram provides a high-level overview of key classes and their relationship in our COVID-19 contact tracing web application. It incorporates security-related classes and methods to address the specified security requirements. It showcases how our application works and which security requirement is implemented here. This is our client server architecture. It has two sides. The first side is the client side. The web platform employs client-side rendering using HTML, CSS, and JavaScript, with the server responding to user requests. Interaction is facilitated through user input, and JavaScript manages client-side logic for an interactive interface. AJAX supports asynchronous server communication without page refresh. Data storage utilizes the cookies and session storage for efficiency. The client side handles from rendering, optimizing platform responsive. Map rendering is achieved using the Mapbox GLS.js library, offering interactive maps with features like zoom in and zoom out. User authentication integrates the Google OAuth API for login, managing tokens and sessions of the client side, and validating tokens through server requests. Overall, the architecture ensures a dynamic and a secure user experience. The other side is called the server side. The application relies on Express.js web framework for managing HTTP requests, responses, cookies, and user routing, including the implementation of business algorithm. The MySQL database stores user data, check-in history, venue history, and email details. Google API authentication enables user authentication using Google credentials, enhancing security. Routing facilitated through files like routes, admin.js, organizers, Mapbox, and Google OAuth API are integrated for additional Functionalities. The Node.js driver established the connection to the MySQL database for operation. API endpoints defined for client-server communication expose functionalities such as user authentication and data retrievals. Error handling and logging, crucial for monitoring and debugging, are managed on the server side. Overall, the server-side components interact seamlessly through HTTP requests, API calls, and database queries, ensuring the platform's smooth functioning. Thank you.
Thank you, Uma, for your presentation. Now I'm going to give a demonstration of this project. So this is our interface of our project. So if a user comes in here, a new user, he has to go to the sign up as a user. So he have to give at least 3 letters to sign up as a username. So he can just give A and it will gonna prompt him back. For the at least have to be 3 characters. So you can just give X, Y, Z just for the testing purpose. I'm just giving test. The email should have @ in it. If it doesn't have any @ in that, it will gonna prompt the user that you have to give the appropriate email. So it says enter a valid email. So we're gonna go up with the valid email. If the password was like just a simple one, suppose 1, 2, 3. So it will gonna prompt like password must at least 8 character long and including uppercase, lowercase, and a number and special character. So I'll give a strong password in here. Give a name. So I'm just giving the test purposes. So his date of birth. You can just give the date of birth in here. Contact number. Gender. Street number. Street name. Street name, we can give anything we want. Suburb. Zip code. And the state. So if we get sign up, says user creation successfully created. So we have to select the type of user in here and we'll give a twist to how we are mitigating another security issue which is brute force attack. So if we give a random password, try to log in, says login failed. I am trying to set the limit, get to the limit. So we get like 3 limits. Now, right now, if I get another wrong in here, it says too many failed attempts, please try again. So we have to wait for 30 seconds because we can't click the login button. So it's disabled for 30 seconds right now. We have to wait for 30 seconds to get enabled again. So it's the login we have done. We can just go in here for check-in. So if we, another security feature that we have implemented is the access prevention. We cannot just give a script, suppose script and says alert, like blah, blah, blah. And close the script in here. If we try to run that one, it will not gonna run because we have sanitized the input and everything. If we go to the history check-in, so it never came up in here. So if we go to the code of our project, we will get to see that one as well. Another thing we have implemented is the session hijacking. So user can't track the cookie and from the front side. If we go to the application and see the storage and the session storage, so there is nothing. There is no session ID and no token. So we made sure that session is only trackable from the back end, not from the front end. So if we go to the core of our project in here, so in here, if you go on the back end of the code, so we have created a custom login. So it will gonna log and monitor whatever is happening to the our project. So if you go to the log, it will gonna log everything. If we go to the sessions where we are setting it, and we are setting the session, so it says HTTP only, and the session taken will be expired for after 30 minutes. Another thing we have done was the DOS attack prevention, as well as it all gonna prevent the brute force attack in backend as well. So we have implemented a rate limit. So after a certain, for 15 minutes, after 15 minutes, within a 15 minutes frame, it will gonna take 150 requests to these APIs. After that, the server will reject any kind of request coming from the front end. I also made sure about that we have if we go to our users, we have implemented a secure encryption for the password, which says it will gonna hash the password, which is not, it cannot be dehashed again. So we have implemented a double security one. If we go to the front end of the sign up process, so when we are sign upping an user, we are also hashing the password before sending it. So in here, what we are doing in here, so our user password is already getting hashed before sending, and on the after receiving it on the backend, it's also getting another hash. So it's a double hash. So user a attacker can't even guess the password because it has been double hashed. Another thing we have done regarding the user segmentation. So if we go to our backend, so it's all the routes for the admins, users, and venues are different. So, and no one can just like escape escape the privilege of an user. So they are all parameterized for the SQL injection as well. So we are executing queries separately. So that's make sure that even if a hacker push an SQL injection, it will not gonna run on the backend. Another thing we have done as if we go to the front end to see what we are going for these are for the XSS sanitization for any kind of input. And if we go to the sign up process, these are the regex that are responsible for validating that user giving everything right. So far, this is all the 9 features that we have discussed in our implemented in our projects. Now go back to the demonstration. So this is the overall 9 security features that we have implemented so far. Thank you everyone for listening to our project and the demonstration. I think everyone have understand. Thank you everyone.